Using the BrØnsted-Lowry definitions of acids and bases opens up more compounds to the collection of acids and bases. Let's look at an example. Ethanoic acid dissociates in water to form ethanoate and hydronium ions. This is a reversible reaction, meaning that hydronium ions can react with ethanoate to give us ethanoic acid and water. For the forward reaction, it is clear that ethanoic acid is the acid and water is the base. What about the backward reaction? It is also an acid-base reaction. Ethanoate is now accepting a proton from hydronium. Hydronium is the acid and ethanoate is the base. Isn't it interesting how an acid can dissociate in water to form a base? This pair has a unique relationship, and so we say that ethanoate is the conjugate base of ethanoic acid. The formal definition of acid-base conjugates is an acid and base pair that differ only in the presence of one proton. By the same definition, Cl- is a conjugate base of HCl. If we looked at it the other way around, then HCl is the conjugate acid of base Cl-. It depends on which way you draw your reaction. It is worth noting that every acid has a conjugate base and every base has to have a conjugate acid. This makes sense because to be an acid, the compound must have at least one proton to donate, meaning that you can lose one proton to form a conjugate base. Likewise, to be a base, the compound must be able to accept at least one proton, which will cause it to become a conjugate acid.